So let's talk about this consistency model in detail because it's very continuing from what we discussed. Now we get the concept of consistency already, right? And in database, in actually in the past, we have what is so-called online transaction processing system. And database is one of the key mechanism for online transaction processing because you have a system that serves user to do something with the UI. It has all the user interface to serve the user. It has all the business rules for doing certain things and store data in the database. Most of the common online transaction processing are what you have experienced. That is either airline booking, either banking, registration system, online shopping, either online or not online. These require the system to retrieve data, read data from database, right? Store data into the database, update, and so on. Do certain data manipulation and requires a lot of data transactions, business transactions. So what is a transaction? If we talk about business transaction, of course, it's different. Business transaction means, yeah. Oh, correct. Thank you. And why the online student does not say anything? This happened. Okay. Sorry, I already talked about the online student. You need to alert me whenever I forgot to do the screen sharing. Okay. We are talking about another new set of slides on the topic of transaction processing and consistency model. Okay. And I was discussing on this transaction, concepts of transaction, and give some example a little bit. And in terms of definition, I believe that we have heard of the term business transactions quite a lot. Okay, but I would like to compare and contrast the term with database transaction as well. So I give you 10 seconds. Think, what is a business transaction? Or what are some examples of business transactions? Okay, so any answer for me or feedback to me? Okay, Faye. Bank transfer. This is the business transaction example, right? We transfer money from one account to another. Okay, any other examples? Anyone wants to share something? Either an example or maybe your understanding of what is a transaction. a business transaction? Nothing? Really? Alvin, can you just say you're sharing while typing? We are in the classroom. Next time I will type my teaching. It will be slow. So what is it, Alvin? Okay, buying item from online. You think this is a business transaction as well? Yes, very good. Anything else? Every team, you have your own project. Okay. Type in the chat if you want the typing or answering. What are examples of business transactions from your project? Yes. Finding the total sales of the last month. Okay. So this is more on the analysis of the data. Okay. Actually, we have two types of system. Can someone find the acronym? You can say it out. No need to type. If you know the acronym, that is easy. It's just right answer or wrong answer. That's it. Because these acronyms are widely referred to. What I already said OLTP before, right? What is OLTP? Online transaction processing. Thank you. What do you think about OLAP? OLAP. Online analytical processing. Yes, thank you. So they are actually different, okay? Right? So that means these must be different as well. So the meaning of transaction usually is to serve business operation in terms of routine business operation, selling product, maybe searching for product is fine, or doing some online transaction related to the service of the business, like making a bank transfer. How about booking an airline? Is it a transaction that a customer, usually business transaction is when a customer wants to accomplish some operation, right? Wants to complete or do some operation related to the business operation, business service or product, buying and selling and so on, okay? But in the database, a transaction is defined as a sequence of actions that read and write or write to and from the database. So a database transaction means a set of this sequence, okay? A sequence, a series of the sequence that usually, if you look into the detail, they could be combination of just read and write operations. But again, it is the definition that is used to define this series of operations in database to fulfill the business transaction. So for example, if we want to say that a transaction is to buy a particular, to make a purchase, a customer make a purchase online. The transaction would mean you need to think of the database system. So what table, if you use relational model, what table you have to insert data into? Maybe it's not only one single table, it's more than one table. Then it is a series of updating to table A, table B, table C with corresponding rows of insertion and so on. Or maybe it's also update. Why? Okay. As I said, make a purchase. Which table we should update? Any of you work on your project that is about selling, buying stuff, right? Fresh to farm and many others too, right? There's also clothing, selling the clothes, even the cloud, what is the name of the system, but making cloud service available for your company user and so on, right? You still need to think of the transaction. It's the same. So making purchase, which table to update? Pardon? Stock? Sure. You need to reduce the stock. Okay, this is if really someone purchased from you, your stock has one item less at least, depending on how many the person buy. What else that you make must update? So this is an update. Order? Do you have order table? Do you have order? Sometimes they call it order what? Order line or what? Depend of what table you call it, right? But you need to add more records into the table. So there are both insert and update. Do we have delete? Maybe no, not yet. But again, to do a purchase, you need to make sure that stock must be updated, order item must be, order record must be inserted, order line must be inserted, or even if you have some other table like total revenue, sales, and so on, maybe they have to be accordingly updated too, right? So there are a series of update operation, read operation, insert operation, and so on that must be done. So these are example of database transaction to fulfill business transaction. So when we talk about transaction in database scenario, we basically talk about the sequence of read and write, sequence of CRUD operation, actually. Okay, thank you. Online food delivery system. Who is this? I cannot. Okay. All right. Thank you, Paramik. Then back to the world of relational database system. There is transaction model, which is called ACID model. Okay. It's a very classic transaction model that people will refer to when we talk about transaction processing system and the transaction property. So I give you 10 seconds. Search if you don't know. What is ACID? At least first, what does it stand for? Okay. Second, what is each of these? Okay, so what do you get? What is A? Pardon? Thank you. Atomicity. Okay, we go for the acronym first, and we go for the definition one by one later. So A for atomicity, C for consistency. Okay, so transaction often requires consistency, right? I for isolation, okay, and D for durability. So this actually, the answer is in the next slide. You just search the slide. Okay, so what is the atomicity? What does it mean? Easy term is all or nothing. When you execute a transaction, if we say that a transaction is a series of database operation, right? Operation 1, 2, 3, 4, 5, such as to reduce the stock, to insert order record, to insert order line record, to insert this and that record. All of these series of operation must be completely executed, successfully executed, all of them, or none of them. So all or nothing, whether you completely execute the whole series sequence or nothing has been executed. This is what you have to ensure for database transaction if you want to impose the transaction rules or properties. Okay, that is atomicity. A good example to illustrate why atomicity is important is this is me and this is you. Okay. Somehow I feel very happy today. I want to transfer 1,000 baht to your account from my account. I'm very kind, right? Okay. So originally I have 2,000 in my bank account, and you have, how much do you have? 0? Okay. Let's say because I feel that you need some money for lunch. Okay, so I need to transfer you something. So a transaction for this bank transfer means that what? Number one, we deduct first or we add first? Maybe we add first. Okay, maybe if it is a bank, I think they will start from deducting 1,000 baht from my account. And that means I will have 1,000 baht remaining. Step number 2, of course, this is actually update, right? Update my account to be 1,000. Then step number 2, update your account to be 1,000, right? That is plus 1. Actually, for me, it's minus 1,000. So your account will become like this. My account become like this. Actually, these are the 2 important updates that must take place. Anything else? Actually, there must be some kind of log keeping and so on, right? But let's make it very simple. First, update my account. Second, update your account. This is 2 actually operations, 2 database operations. All or nothing means either if something happened and the transaction must be canceled, then my account should become 2,000 baht and your account is zero, right? But if transaction is not guaranteed, transaction property is not guaranteed. Something happened after step 1 complete. My account has only 1,000 baht remaining. But step 2 has not yet completed its execution yet, meaning that you have still zero. But mine has already reduced to be 1,000. Is it acceptable? Not acceptable for me and not acceptable for you too, right? I lose 1,000 baht and you also don't get 1,000 baht too. And the money is gone. So atomicity means if a transaction comprises a series or sequence of operations, all of these operations must be successfully executed, all of them. If something happens that is only partial operations are executed, then when the database system gets back, something happened like the system crash, the power fell or network fail and so on. When something is back to the full operation, everything will be considered, we call it rollback, okay? The transaction will be rolled back to the beginning stage as of nothing has happened. So that is the property of transaction. We don't allow partial execution of a transaction. So we roll back to the beginning stage as the transaction never executes. And if you want to re-execute that transaction, fine. Okay, but otherwise, the database is restored to the before transaction execution state. So this is the first property, atomicity. We need to ensure no transaction has some kind of partial execution. Okay. Second is what? Consistency, of course. Execution of transaction will put the database in consistent state. Okay. And isolation. Every transaction can be executed concurrently as of they are not interfering with each other. So they have kind of could be isolated. And durability, once transaction is said to be complete or commit, nobody can change it back. Unless, of course, you already transfer the money and I feel unhappy, right? I will contact the bank, but of course I need to initiate the cancellation as another transaction. But it's not by the system. The system will make it already complete. So the durability means after transaction complete, it is permanent. Okay. So this is actually, yeah, all the definition. And oops, someone say something. Okay, thank you. This discussion wants to state that this ACID model of transaction is very important in the relational database system world and in the business transaction processing world because of its property as we already discussed, right? We should not allow some partial execution of a transaction because it makes a lot of problems to the business. You cannot place an order, right, while you reduce already the inventory and stock, but again, the order has not been properly placed. Bank transfer is not done completely, right? Something like that. There are a lot of problems to happen if transaction property are not well maintained. But the challenge is that when your database system is centralized, that is easy. Somehow still transaction is not easy concept. to maintain because you allow concurrent execution of thousands of transactions at the same time. So that makes already complicated. But the complicated mechanism is even introduced when we are talking about cluster-oriented structure or distributed data structure too, because data is now propagated many places, distributed in many of the nodes and so on. The concept of consistency is one of the very challenging property to maintain due to the characteristic of distributed nodes. Okay. And that is why there are certain changes in relational database system. Strong consistency concept is well restricted. Okay. But in NoSQL, certain relaxation is introduced in terms of the consistency of the data, in which we will discuss a little bit. Okay, there are different forms and different degrees of consistency that we should discuss. First, when we talk about consistency, let's look at these two different definitions. Usually, reading alone never make any consistency problem. Consistency will occur when two operations, write operations, at least two write operations want to write the same piece of data. That often lead to consistency. So whenever there is a write operation, consistency problem could occur. Reading never cause any consistency problem. Why? Even single write, there could be read-write conflict. I'm reading something while you are updating something at the same thing. For example, I'm checking the price of the product. Okay. But you are the admin of the company. Okay, you are updating that product's price. So you want to increase the product price, but I'm reading it, right? So you increase by 10%, but when I read, perhaps it's actually at the same time or very small difference in terms of the time. I read the old value of 100 baht, but you are now changing it to 110. If I don't see the latest update yet from my reading, I still see the old copy of the data, right? Not the 110 that you already updated. So this is, again, read and write conflict. Two users one try to read, one try to write the same copy of data, but we see different values. So this is read-write conflict. And there is also a lot of problem with reading consistency. And they are called read-write conflicts or inconsistent read or dirty read. We read something that has already been replaced, that is dirty read. And inconsistent read means different people, different users read and then get different values because the consistency has not yet arrived into these multiple data nodes and so on. And write conflict, that write and write conflict, I think this is easy to understand because two transactions, two users, for example, try to update the same data at the same time, but of course there will be a lost update. If you compete to update this same piece of data, such as product price, originally is 100. User A wants to change it to 200. User B wants to change it to 300. So The update by user A, of course, is lost if it has been replaced by user B. The thing is, actually, it should not be like that. Okay, let me make a clear example. Suppose you get instructed by your sales manager that every product item should be increased by 10% in terms of the price. Okay, you are taking care of this product line, user A. So he wants to change by 10%, right? Okay, then I am updating it to 110. Okay, and at the same time, this user perhaps does not know, or somehow there could be a problem and want to re-update and so on, and then update it again another 10% and so on. There will be a lot of possible problems in terms of right and right conflict if good mechanisms have not been implemented to prevent. Usually in the transaction processing, they will use some kind of locking mechanism. You will never allow to update the same piece of data until it is unlocked or something like that. But there are a lot of detail that I will not go into that deep detail, but just to introduce you to understand the concept. Okay, so several forms of problems could occur related to consistency issue, especially this issue will come from attempt to write data, write or update data at the same time. So this is the problem of consistency. And I think this scenario show another form of consistency when there are multiple data replications. That is, we use peer-to-peer replication, for example, right? From last time, you have data in Mumbai, in London, in Boston, okay? What happened is that here, first, number one, Pramod books the last hotel room from this Mumbai node. Then, of course, the data must be propagated, the update must be propagated, right? This update of the last hotel room booking should be propagated to all nodes so that other users don't see the room available, right? But if the consistency does not happen in good time, what could happen is that Martin, here, number 2, Martin still sees that the room is available because the update has not yet been processed in the London node. But if the propagation arrives, but not to every node, right? The synchronization and replication, of course, takes time from node to node. In Boston, of course, this propagation already takes place. Cindy sees that the room is not available, so this is good. But now, this is also a problem. Inconsistent reads. 2 users read the same data from different places, but see different value. Right? These can be replication. This can also be the master-slave model, right? This can be a master. Allow writing. Both nodes here allow only reading, but even we use master-slave or peer-to-peer replication, still problem could happen the same. not not even helping, right? So replication consistency means that we need to make sure that different copies of the data should have seen the same values. And that is called replication consistency. And when we talk about consistency, as I said, it's perhaps sometimes not very possible to expect real time or immediately, right? So that is the concept of inconsistency window. How long time does it take for all the nodes to have all consistent data? So the inconsistency window means the length of time that we still have inconsistency because it takes some time, right, to propagate the change. And this is what we already discussed. When we cannot expect immediate consistency, a relaxed term is eventual consistency. It will take time, so it means eventually they all will become consistent, but it takes some time for all the change to take place everywhere. Okay, I think you have experienced this. Have you? Have you ever posted a message in a social network and you refresh and somehow you don't see your own post? That is because sometimes you write, you make your post here. But when you read, refresh and read, it somehow read from another node. Then the post is not there yet. You cannot guarantee, right, which data node you actually reading from sometimes. Okay. Another form of consistency that we discussed in NoSQL and in distributed environment is user perceived consistency. It really depends. You need to analyze for your application the time expected by the customer to see the updated value. And actually, as I said, different application domain, business applications, these expected time could be different. In terms of, as I said, social media, maybe we are a little bit relaxed to see it. In terms of very financial, financial application, financial sector, right? They might expect the time, the inconsistency window to be very short. Okay. And they are even read your own right consistency to make sure that you will see your own update. You may not know whether others have seen your update or not, but you will see, because then you feel relief that whatever you make change to the database, okay, it has already been there. But keep in mind as well that mostly, whether it is this scenario or this application or something else, when you make a change here, your change propagated to somewhere else will take some time for sure, right? Depending on how many of the distributed nodes you have in the whole network. If it is just 2, okay, it may be fast. If it is a lot, and also which model you use, it is a hybrid model or not. Remember last time we even have, this is a master for this piece, this is sharding, combining sharding and also replication together and so on, right? So whenever this is very complicated, it takes even longer time, okay? So it will take some time. So even you make change here, And if you read your change from here, it will be fine. But if you read the change from here and the change has not arrived there yet, of course, you will not see the change. So it is for this, if the system guarantee read your right consistency, it will try to make sure that you read from the same note every time so that you can see your own change and you don't feel worried. Okay. There is also session consistency concept that is just to guarantee the user session, the consistency within the user session concept. Okay. And when we talk about the degree of consistency, if we impose strong consistency model, it means that once you get confirmed that your update is complete, it means all the change has already been propagated to everywhere. But it may take some time for you to get the confirm, right? But once you get confirmed, it guarantees that everyone see the change. So these will never have this. If you use the strong consistency model in your system, this scenario will not happen. Because once it is confirmed to you that you already get the last hotel room, it means everyone else everywhere in the distributed network must have already been updated properly. That is strong consistency. But again, as I said, strong consistency may have high latency, right? Slow. You may need to wait because all the updates need to be sure to update everywhere and then confirm to you. But you will not feel doubt whether there will be somehow later on say to you that there's a problem of confirming your booking, your room, your this and your that. Okay. So strong consistency could be important for certain types of application for sure. You may not want user to be able to argue with you once they commit certain transaction, right? But another form, another relaxing degree, okay, is the weak consistency and eventual consistency. Okay, so for this weak consistency, it means that there will be inconsistency window. There is a time. Once, so it means this can happen. With this means weak consistency. Once an update has been made, it may have certain inconsistency window time for the other nodes to see the change. Okay. For all nodes to see the change you have made, it would take some time with the weak consistency. And actually, this is kind of the same in the sense that with weak consistency or eventual consistency, it's kind of not guaranteeing in terms of the after you execute certain change, it doesn't guarantee that every other node will immediately see the change, but it guarantees in the sense that after some time has passed, such as inconsistency window, all the changes will be done will be taken place properly in all nodes. But with this, you can see some of the relaxation rules a little bit. If there is no new updates made, because if every time people keep updating, right? Eventual consistency means that all nodes in the network will actually contain the same value. But it's not that the update has to be propagated from this node to all the other, right? There are still some changes happen everywhere. So the synchronization of all the nodes must be taken place. And when there's a stable period, no one make any change, of course, everything will kind of converge to the same consistency, right? And that is why we use the term eventual consistency. Eventually, when no one makes any change, everything will be consistent. So it's the same as weak consistency, but just to say that it will take some time. But usually we have these two, strong versus weak. When you want to choose the consistency model of your application, you want it strong or you can tolerate some inconsistency a little bit. But with the toleration of inconsistency, the latency can be improved, right? You reduce problem of slow response and so on. And again, every time I will insist on this. There is no right solution or right answer for every application. You need to really consider that which form of consistency is acceptable, which degree of consistency is acceptable, depending on the client application and the requirements. Okay. Okay. This slide just summarizes that when could be the case, you might want to consider some relaxation of the consistency of your data. Such as, first case, that you may want to relax or tolerate the inconsistency a little bit. For sure, inconsistency can, if you can accept some degree of inconsistency for certain inconsistent window, right? It improves read and write performance because you don't need to wait for all the data to be updated and then you start another new update and so on, right? So for highly concurrent condition of multiple users, massive number of users using system at the same time, improving read and write would mean to relax the consistency model a little bit. And also when there is a partitioning occurring, there's a network partitioning. As we discussed, you need to choose whether you make your system unavailable or you tolerate the consistency during that network partition period. Okay. And this base is just, it's not very theoretical, but I think they introduced this for the NoSQL in order to kind of contradict with the very strong ACID model of relational database. With relational database, transaction follow strictly ACID model, right? But then with NoSQL, they want to always propose something opposite. And that is why we have what is called base transaction model instead of acid, which stands for basically available soft state and eventual consistency for the BASE. So for NoSQL, you could see clearly that NoSQL somehow would value availability more than consistency, but maybe not kind of zero consistency, right? But partial consistency. So this basic availability for the base model means that the system would guarantee availability, but maybe in partial consistency or weaker form of consistency. Okay. And with the soft state, it means the system state change over time. Okay. And in the past, if you are experienced users, database administrator, experienced database administrator of relational database system, you will know that in most cases, the RDBMS take care of a lot of things. Even the transaction processing, ACID model, and many more, right? It's all done by DBMS, all taken care and responsible to ensure that our data is well protected, well consistent, and very accurate, and so on. But in some of the development system nowadays, okay, development team's perspective, sometimes data consistency is considered to be what developer needs to take care. The database system, database engine may not guarantee data consistency or handle data consistency completely, but to a certain extent. But then it is the job of developer to write the code somehow that guarantee or make sure to achieve data consistency in certain level according to the application requirements. Okay. And then for the eventual consistency, we already discussed. Okay, the consistency could be delayed. It would take some time for the data to in all nodes to be converged into same consistent model. It would take some time. So that is why we said eventual consistency. So this is very much opposite to the immediate consistency of ACID. As I already mentioned, ACID impose very strong consistency model. Once the transaction complete, the update confirmed to you, it means all the nodes already have consistent value of what you have changed to your data system. Okay. So in conclusion, if we talk about base transaction, okay, availability has the highest value. For base transaction, it values availability the most. For ACID transaction, it values consistency the most. So these are two different extremes. Not really extreme, but two different properties that different models try to achieve. And again, there's no right and wrong. It really depends on your application, which one is more suitable. Okay. Okay. With Bayes, of course, I think this is just to summarize, right? We already discussed this. Consistency at right time of all the replicated data is not guaranteed at the right time, but eventually it will be guaranteed. Okay. It is a less strict. Okay. Yes, data consistency will be in the future. Okay. So I think this is the key summary of this. Okay, so be sure that you understand these two different acid versus base and all types of consistency, and be able to choose or to understand which one would be more appropriate to your application when you design the data system. Okay. All right, any questions so far?